This video is about using congruent triangles in a proof, and it comes from your text sections 4-3 and 4-5 combined. Proving that two triangles are congruent can be a very useful middle step in a longer proof. That doesn't always have to be the end goal. We can use it along the way. For example, suppose you're asked to prove that two angles are congruent. Oh no, what if there are no vertical angles or parallel lines? How could you prove two angles congruent? You may be able to prove the angles congruent by way of triangle congruency, this middle step here. So, for example, suppose from your diagram and the other givens, you could find a triangle congruency postulate or theorem to show that two triangles are congruent. And suppose that the corresponding parts of those two triangles were some of the angles that you were trying to show were congruent. You could use CPCTC to show that the required angles are congruent. Similarly, you might be able to prove that two segments are congruent to each other by way of proving that two triangles are congruent. So the steps for using this method are, number one, what end product are you looking for? Write down what you want to show, maybe at the bottom of your page. Step two, can you find two triangles in which those angles or segments are corresponding parts? Step three, can you prove those triangles congruent using only given information and legal deductive reasoning? In other words, we're not going to use circular reasoning here. We're not going to use the end product, what we're looking for, to prove the triangle's congruent. We need to use the other information that's already been given or deduced. If so, then you can use this proof outline to show that the required parts, whatever you're asked for, are congruent.
Every night, I want you to hold Marvin the cat. He's not a real cat. You text me. I don't want you to text me. You're stupid.
Example 1. What steps could lead you to prove that line QP is parallel to line ST? I'm not going to mark them parallel because that's what I'm wanting to prove. List your reasons in order. Okay, we're given QS and PT bisect each other at point R. Okay, let's pull that statement apart. QS is bisected at point R, so QR must be congruent to RS. PT is also bisected at point R since the two segments bisect each other. But I have to be careful only to mark PR congruent to RT. I can't mark all four of these segments congruent because all I know is that R is the midpoint of PT and R is the midpoint of QS. So if we want to prove that QP is parallel to ST, I'm going to write that at the bottom of my page. QP is parallel to ST. That's where I want to be going with this. Backing up one step, do I see any parts of these two triangles that I might want to prove congruent? Well, I have alternate interior angles, two pairs of them in fact. So if I could prove angle S and angle Q were congruent to each other, then I would be all set. I would be able to say that these two lines were parallel. So I'm going to say angle Q is congruent to angle S with a question mark on it. That would be one way I could go about this proof. Well, are angle Q and angle S corresponding parts of congruent triangles? They might be. I could see that being the case. One other thing that I see on this diagram that I didn't mark before is this vertical angle pair. So now it looks like I have SAS congruent to SAS, and that is a triangle congruency theorem. So I can say for sure that triangle, let's go in order here, PRQ is congruent to triangle TRS. Are Q and S corresponding parts of those triangles? Well, Q and S are listed as the last vertex of the triangle. So yes, they are corresponding parts of these two triangles. So I can get rid of the question mark and say that for sure. So I have the last three steps of the proof outlined here. And all I need to do is write down the information that led me to conclude this by way of the triangle congruency theorem SAS. So I was given P, well, by the definition of a midpoint, PR equals TR, QR equals SR, and then I spotted a pair of vertical angles. So angle PRQ is congruent to angle TRS. So vertical angles led me to conclude that. That would be on my arrow. And these things come from the definition of a midpoint. And I should actually write congruent instead of equal. I should make them segments. And these three facts together came together by SAS to prove the triangle's congruent. Then I had CPTCP, and then I had, on this step, alternate interior angles converse. So listing the steps that could lead me to this proof would be the definition of a midpoint, vertical angles are congruent, the SAS congruency postulate, CPTCP, and finally the AIA converse. Those would be the steps that I used to prove QP was parallel to ST. You try. What steps could lead you to prove that R is the midpoint of QS? List your reasons in order. If you're given that R is the midpoint of PT, so let's mark PR and RT congruent, and we're given angle Q is congruent to angle S. Give it a try. Example 2, what steps could lead you to prove that angle H was congruent to angle F? So what I'm looking for in the end is angle H congruent to angle F. So hopefully I can find some triangles for which H and F are corresponding parts. I'm hoping that I'm going to be able to say CPCTC from two triangles in this picture. Okay, let's mark the rest of the given information. EF is perpendicular to EG. HG is perpendicular to EG. EH is congruent to GF. Okay, I have two right triangles and I have their hypotenuses congruent because this hypotenuse is opposite of that right angle. This hypotenuse is opposite of this right angle. So I'm on the right track here, and I'm noticing that the two right triangles here share a leg. EG is congruent to itself by the reflexive property. So I have the HL congruency theorem here ready to use. So I can say triangle GEF is congruent to, now I'm going to have to make sure I say these sides in the right order. The first side has to be the one that's congruent to GE. So I'm going to say EG because we're going the other way around. Triangle EGH. And just as a double check, I have my right angle in the middle in both cases, which is a good indication that I've written them in the correct order. So what did I use to get to that step? I used the HL congruency theorem. And how did I find the HL theorem? Well, I had some givens. I also had that EG is congruent to itself, GE, by the reflexive property. And that was just simply from the diagram. I also needed to use the HL theorem. I also needed, I'm going to put this coming in from the side here, that EH and FG were congruent. EH is congruent to FG, which was a given. And I also needed another given. I have three arrows coming together to form this HL congruency theorem. I also needed the fact that FEG and HGE were right angles, or these givens here. I'm just going to put that on the end of this arrow. Okay, so that's a given, this was a given, and the diagram was a given. So what I've used in the order that I used them was the reflexive property, the HL theorem, and CPC-TC. You try this one. What steps could lead you to prove that angle TSA is congruent to angle STR? If you're given that RT is congruent to AS, you could use colors maybe to color in those two sides on your diagram. And you're given RS is congruent to AT. What steps could lead you to prove this fact in the end? For further practice, see page 130, numbers 3 to 11 odd.